Hi everyone, so in this video we're going to be talking about graphs of functions. So specifically we are going to be plugging in some x values to check on what y values go with them, plotting those points to get some basic shapes of some basic parent functions. And these functions are going to be the baseline for whenever we start to talk about transformations. These are going to be the functions that are the parents of a whole bunch of other ones that we're going to start moving around. Okay, so in order to do this, we're literally just going to pick some x values, find the y values that go with them by just plugging them into the function, and then we're going to see what they look like. To start off, we have f of x equals x. Now, hopefully this one already looks familiar. There's nothing being done to x, so this is the same as just saying y equals x. So this is just a line. That's it, just a regular line. All right? So if we plug in some values like -2, -1, 0, 1, and 2, which are going to be our values for most of these. If we plug these in, then f of x, well, it equals x. So it's going to give us the same exact stuff back out. So what that looks like is we have -2, -2, -1, -1, 0, 0, 1, 1, 2, 2. And if we draw the line through those, that is this function. Right? For domain and range, remember it's leftmost to rightmost and bottom to top. So for domain, there's arrows on both ends, so -infinity to infinity. And the range is going to be the same thing, still arrows on bottom and arrows on top, so -infinity to infinity. All right, easy one out of the way. Let's go ahead and get into some ones that you're probably a little less familiar with. So starting with x squared. So we're going to, again, start with some x values. -2, -1, 0, 1, and 2. So to figure out g of x, to figure out the y value, all we're going to do is plug these into the function, which just means we are going to square each one of these values. And notice I am putting parentheses around anything with a negative in it. Those parentheses are important whenever you are squaring, so make sure you put those. So -2 squared is +4. -1 squared is +1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So let's go ahead and plot these. -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. Now, again, we're going to connect all of these points, but this time they can't be connected in a straight line. So we're going to end up with something that's a bit curved. It's going to look kind of like a U. This one's called a parabola. For domain and range, it is -infinity to infinity for the domain. And for the range, it is 0 at the bottom to infinity at the top. Right? So, especially for later, make sure that you have these points handy for x squared. Our next one is going to be x cubed. All right, again, we're going to go ahead and do these same x values, so -2, 1, 0, 1, 2. And this time, we're going to be cubing all of these things. So it's going to be -2 cubed, -1 cubed, 0 cubed, 1 cubed, 2 cubed. -2 cubed is -8. -1 cubed is -1. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. So let's go ahead and draw these. -2, 8. It's going to be all the way up here at top. -2, -8 should be all the way down here at the bottom, not the top. -1, -1 will be right here. 0, 0, 1, 1, 2, 8. All right, again, this one can't have a straight line drawn through it. So it is going to curve, then start going back up. This is the graph of x cubed. For the domain and range, it keeps going to the left and right forever. It keeps going from bottom to top forever. So -infinity to infinity for both. Next up, absolute value of x. Right. So recall that absolute value of x just means make this positive. So like the absolute value of -10 is +10. The absolute value of +10 would still be +10 because it's already positive. All right? It doesn't necessarily mean change the sign, it just means make it positive. So let's go ahead and use the same ones, -2, -1, 0, 1, and 2. So first off, if we plug all of these in, so absolute value of -2, absolute value of -1, of 0, of 1, and of 2. Absolute value of -2 is +2, because we make it positive. Absolute value of -1 is +1. Absolute value of the rest are just themselves. They're already positive. Don't do anything to them. All right, let's go ahead and graph these. So -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. Now, this one actually does not curve. Instead, it's two straight lines. One over here, and one coming out to the right. This is the graph of absolute value. All right, so it looks like a V. All right, for domain, again, left and right forever, -infinity to infinity. For the range, the bottom is 0, but the top can go on forever, so infinity. All right, square root of x. So this time we're not going to do 5 points, and we're also not going to do our normal points either. So remember, whatever we pick for x, we're going to have to plug into the function. In this case, it means we're going to have to take the square root of the number. Well, first off, all negative numbers are out then. Because if we take the square root of a negative number, then we get an imaginary number, but there's no place on this graph to put imaginary numbers. So we're not going to use those. So we're only going to deal with positive numbers, and in particular, I'm going to pick 0, 1, and 4 because I know that I can do the square root easily of all of those three. So if we do the square root of 0, square root of 1, and square root of 4. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. So let's plot those. 0, 0, 1, 1, 4, 2. This one curves off to the right like this. But if you notice, it does have a definite stopping point right here at 0, 0. So this one's domain is not negative infinity to infinity. Instead, it is 0 to infinity because it stops on the left at 0. Same thing with the range. It doesn't go down past 0. It's going to be 0 to infinity there as well. All right, last one is going to be the cube root of x. So again, similarly to the square root, I'm going to pick ones that I know I can do the cube root of easily. So I'm going to pick -8, -1, 0, 1, and 8. Because we're going to have to take the cube root of all of these. So the cube root of -8 is -2. Keep in mind, cube root is not the same as square root. You can take the cube root of negative numbers. Cube root of -1 is -1. Cube root of 0 is 0. Cube root of 1 is 1. And I put cube root of 2. That is supposed to be cube root of 8. I accidentally gave away the answer because it is 2. All right, so if we go ahead and graph all of these, it's going to be -8, -2. It's right here on the edge. -1, -1, 0, 0, 1, 1, 8, 2. Again, this one's going to curve very similarly to the cubic function, just this one's going to be on its side. It's going to go up and then over like that. And again, just like the cubic function, this one goes left and right forever, down and up forever. So this one's going to be -infinity to infinity on both the domain and range. Right? So any function that you don't know the shape of, you can always figure out at least a basic idea of how it looks just by plugging in some x values, finding the y values that go with them, and then plotting those. That'll give you the basic shape. Right? So hopefully this at least showed how to plug in some x values and find some y values. And hopefully this gives you an idea of the basic shape of these parent functions, because we are going to be using this whenever we get to transformations in order to have these points and not have to do all of this work again, that we can use those and start moving them around. Right. That said, though, that is it for this video. So thank you for watching.